previous lecture, we will discuss about recursion tree method, what is recursion tree method, how we can use it. So first of all, in previous lecture we discussed about master method. Master method can be used if there is a specific type of equation recurrence, then we can use master method. However, recursion tree method can be used for number of type of equations, recurrences. A recursion tree model can model the cost time of recursive execution of algorithm. We have already seen an example of recursion tree method recurrence equation in using merge sort. So recursion tree method can sometimes be unreliable, but it is mostly used and it can generate good guess for the substitution method, which we will discuss later on. So how recursion tree can be used? First, we will start with simple example, then we will use more complicated examples. So let's start with simple example. As we have earlier done this type of recurrence for merge sort. So in merge sort, we have divided the algorithm into two parts, and at each step, the problem is divided into two portions. So this is the recurrence equation for merge sort. Next, just wait a minute. Next, so here, how we can draw recursion tree for this equation. First of all, this is the equation T of n time for n element. So for four recurrence, we have divided into two portions, and each sub-problem is halved. Like first, we have T of n, like here T of n. Then it is partitioned into two sub-problems, and solve two sub-problems T of n, because it is divided into two portions. So this tree has two childs. Each child has size T of n by 2, T of n by 2. So when we merge it, then or combine it, we have Cn for combined time, as we have discussed in merge sort. Next, each subproblem T of n by 2 can be again divided into two portions. So it could be 2t n by 4. If we put instead of n, we put n by 2, so it will be n by 4. Like here, in previous slide, it was t n by 2. So if we put equation t n by 2 here, just wait a minute. N by 2 should be equal to 2. Instead of n, we put can all of you please mute your mic so we can have a question and answer later on. T n over 2 over 2. This n over 2 is the value which we have placed instead of n. So the resultant equation should be 2t n over 4 plus c n over 2. In this manner, we can solve it like uh, next page. So if we put t n by 2 value, it should be 2t n by 4, like np n by 4, t n by 4, and c n by 2. And similarly, we put values, same values like. So if we have n by 4, then what will be the result? Like t n by 4, it should be equal to 2t n by 8 plus c n by 4. So we'll put these values in instead of t n by 4 to get the result. Like here, c n by 4, c n by 4, c n by 4. We will put values similarly at each step, and we will continue until we get 1, theta of 1, or n by n elements divided by n elements is equal to theta 1. This process continues, and next this will be a hold for all of it, and the height of the tree will be log base 2n. It should be like this one, because at each step we are dividing the n into half, then uh, again half, and again half until we get 1. So height of the tree should be log base 2n. In book, it is mentioned log base 2 is written like LGN. The cost at each step should be summed, like at first step it is Cn. At the next step, if we sum Cn by 2 plus Cn by 2, we will get Cn. And similarly, at the latter level, we will get Cn, like Cn by 2, Cn by 2, and next level again Cn, and this will continue at each level. If we sum, it will be Cn, and at last level there will be n leaves, so it will be theta n, because theta 1, theta 1, it, all leaves, there will be n leaves, so it should be theta n. So if we sum all Cn, the result will be n log n. If you find it difficult how it is, like if we have like 2 multiplied by 2, or 2 plus 2 plus 2, I will write here. 2 plus 2 plus 2 is equal to 3 times 2. The same concept is used here. All Cn are added, Cn plus Cn plus Cn plus Cn. So all Cn, and these are repeated, or height of the tree is log base 2n. So the result will be n log n using the recursion. This was the simplest example. We will discuss some advanced examples now. The example we discussed there a little while ago, there were two childs and each child have an equal size. But in this example, T of n is equal to T n by 4. Two child, one child size is different, another is different, and then this is the time. So if we solve this first T of n, like previous example, then if we put T of n value, then it will be n square and two childs, first child T n by 4 and second child T n by 2. Like here, it has three components, T n by 4, T n by 2, and n square. Next, we will put the value of T n by 4 and T n by 2. So if we put T, yes, I think I have a question. You can ask question if anybody. So if we put here instead of Tn, we put n by 4, then what will be the result? Let's write here. T of n by 4 should be equal to T of n by 16, because here n by 4, and if we put instead of n by 4, it should be n by 16 plus T. Instead, if we put here n by 4, then it should be n by 8. Plus Cn square. So in if we put here n by 4, then its result should be n by 4 square.
सर आवाज नहीं आ रही
आवाज सबको आ रही है?
सर आपकी आवाज आपकी आती है लेकिन बहुत ज्यादा कट कट के आ रही है बीच में, तो सर वो कई वर्ड
perhaps it will be internet connection problem. So the solution will be, I will upload the slides video on YouTube, then you can see the recording from it.
Sure.
Okay, next. See, you should all of you should अपने mics जो है mute कर लें kindly. So if we put n by 4, the result will be n by 4 square into T n by 16 into T n by 8, and the other child has n by 2 elements. So if we put n by 2, the result will be T n by 2 is equal to T n by 8, because if we put n by 2, then it will be n by 8, and here if we put n by 2, then it will be n by 4. Plus cn square, so it should be n by 2 square. I have told all of you to mute your mics because this video will be uploaded on YouTube. Otherwise, I will not disable you from this video lecture. So if we put n by 2 here, so this will be the result. Till now, any question? Next, the process will continue. We will put n square, then n by 4, then again n by 4 in each step, and we will continue till the leaf node where we have theta 1. And some childs in this tree will have. I've told you to please mute your mic. I'm seeing Mr. Zahir Ramzan. So this process will continue till we get a 1, theta 1. So if we sum at each level, the first level sum will be n square, the next level will be 5 over 16 n square. Why it is so? Because if we put take square, it should be n square over 16 plus n square over 4, and if we sum it, then it will be 5 over 16 n square. Like I can't draw a square here. It will be you can solve it 5 over 16. At next level, it should be 25 over 256, and this process will continue till the leaf nodes. And if we sum each level, like previously in previous example, the sum was equal, so we did the result. But in this problem, we will get a geometric series like n square 1 plus 5 over 16, then 5 over 16 square plus 5 over 16 cube, and this process will continue. And if we solve this geometric series, then we will get the resultant tree, which is the result of this recursive method, which is recursion tree method, is theta n square. So if any of you have a question, you can ask now. There are many examples in the exercise of book. If you have a question, you can ask. So I think nobody has a question. Thank you very much.
सर आपने मना किया है इररेलेवेंट क्वेश्चन ना पूछे, बाद में रिकॉर्डिंग देखिए।
इररेलेवेंट का है, रेलेवेंट आप जितना मर्जी पूछ
सर आवाज का जो सीक्वेंस है उसमें रेलेवेंट क्वेश्चन आ ही नहीं सकता।
चलिए ठीक है, थैंक यू वेरी मच।
सर ये लेक्चर कौन से चैनल पे अपलोड होगा?
मैं आपको लिंक शेयर कर दूँ।